Okay, everybody, it's time to talk about functions. So this is 2.1 part 1. So let's just get a few definitions out of the way to begin with. A relation is defined as a set of ordered pairs. So if you look down here at example 1, this is called a relation because you have these little squiggly lines that mean, or squiggly brackets that mean it's a set, and it has ordered pairs inside it. It's a set of ordered pairs. A function is a special relation. Excuse me. A function is a relation where no two ordered pairs have the same first coordinate with different second coordinates. In other words, the x's don't repeat with different y's. So look at this first example again. Would this be a function? Well, we know it's a relation. We just talked about that. But if you look at this one right here, the x's spot, we have two negative 3's. It would be okay if their y's were also the same, but their y's are different. So in this example, the negative 3's repeat with different y's, so this is not a function. How about example 2? Would this one be a function? Our x's are -1, 3, -4. All of our x's are different, so yes, this one is a function. How about number 3? We have a 1 to 5 cost $9.40 each, and 5 to 10 cost $8.75 each. If you were to write out ordered pairs for this, you would have 1, 940, 2, 940, 3, 940, 4, 940, 5, 940, but then you also have 5, 875. We could stop right there, couldn't we? Here we have repeating x's with different y's. That means it is not a function. What if this had been a 4 right here? If that had been a 4, then this would be a function because you wouldn't have any repeating x's. So there's another way to determine if you have a function. It's called the vertical line test. If you could draw a vertical line anywhere on the graph and it does not intersect it in more than one place, then it is a function. So like this red example here. We could draw all kinds of vertical lines and it would never touch this in more than one place. So this one is a function. How about this one? Vertical line test. Yes, it's a function. How about this one? You can just draw one and see that it touches it in two places. This is not a function. This one? Again, draw one line. You can see it touches it in more than one place. This is not a function. So why is this the definition of the vertical line test? Well, let's just plot a couple of points. Let's say that this is 1, I don't even know how to do this. There we go. 1, 2, we'll just pretend, or 1, 3, we'll pretend. That's the point 1, 3. If I wanted to have repeating x's, I would need 1 something, right? Let's say 1, 5. That would have given me repeating x's. That's what makes this vertical line. Whenever you have repeating x's, you get vertical lines. So that's why it's the definition of the vertical line test. So what if you have just a function and you need to determine if that is a function of x? Well, you could do something like pick something for x. For example, try 2. So you have absolute value of y equals 2. Well, you guys remember how to solve absolute value equations, right? You have two cases. Y equals the positive case and y equals the negative case. Make your ordered pairs out of that. We said x is 2, but when we said x is 2, we got y is 2. But we also got y is -2. So would this define a function? We have repeating x's with different y's. This is not a function. Okay, so what if it's not quite so easy to determine that? Have a look at this one. Number 2. We need to determine if we're ever going to have repeating x's with different y's. Do you know what this is the equation of? This is a parabola because it's a quadratic function, right? If you're not sure, you could even graph it on your calculator. Y equals, if you solve for y, you'll already have it. Y equals all this number. So no matter what you put in here for x, you're always going to get a different y. So, yes, this one is a function. You can also graph it. When you do, you'll see it looks like this. And you can do the vertical line test. So what about number 3? That one's not quite so easy to figure out. So what if we did solve this for y? We need to subtract this x squared from both sides. So we get y squared equals negative x squared plus 1. And then to get rid of the square, we have to take the square root of both sides. Well, don't forget, when you take the square root of both sides, you have to take the positive and the negative solution. So you get y is equal to plus or minus the square root of negative x squared plus 1. Well, have a look at this. Every time you put an x in here, it doesn't matter what it is, whatever that number is, you're going to put an x in there, and you're going to get the positive for the y, whatever it happens to be. Then that same value for x, you're going to get the negative value for y. So you're going to have repeating x's with different y's. That means this is not a function. Well, think of it another way. What kind of equation is this? We just studied this in chapter 1. This is the equation for a circle. Are circles functions? Here's your circle. Vertical line test. It's not a function. So there's a couple of ways you can go about figuring all of these out. So how about this one? What kind of equation is it? It's linear, right? Well, what if you don't know that? Subtract 3x from both sides so we can solve for y. So negative 4y is negative 3x plus 8. Now we divide both sides by negative 4. And we get y is equal to 3/4 x minus 2. Now this is in slope-intercept form. Whatever you put in for x, you're going to get just one value for y. Or you can graph it and see that it is a straight line with a positive slope. So it's going to look something like this. So yes, this one is a function. Finally, number 5. Solve it for y. We get y squared equals negative x cubed. Then you have to take the square root of both sides. Don't forget plus or minus. So you get y is equal to plus or minus the square root of negative x cubed. This looks just like number 3, right? We have this plus or minus over here. So whatever we put in for x, we're going to get out a positive for y and a negative for y. So this is not a function. So how about domain and range? Remember, domain is the set of all first coordinates or the set of all x values. So the range down here at the bottom is the set of all second coordinates or the set of all y values. So how do you determine domain? Ask yourself this question. What is x not allowed to be? Right now there are only 2 things that will limit what x can be. If you have an x under a square root, or if you have an x in the denominator. If you have an x under the square root, the whole radicand, whatever is underneath here, cannot be negative. If it's negative, you get an imaginary number. Then you couldn't graph it. So it wouldn't be a function. So you need to make sure that your radicand under a square root or any even root is positive. could also be 0. That's why we have this. X is greater than or equal to 0. If you have a fraction and you have an x in the denominator, the whole denominator can't be 0. So in this case, x cannot be 0. So what about these examples? What is the domain? Well, remember, whatever's under a radical, under a square root, cannot be negative. So x minus 2 must be greater than or equal to 0. Add 2 to both sides, so x must be greater than or equal to 2. This would be your domain, because you can't let what's underneath the radical be negative. That would make this x greater than or equal to 2. So how about number 2? You have a fraction, so you have an x in the denominator. Remember, the entire denominator cannot be 0. In the first one, we said the entire radicand cannot be negative. So make sure you know the difference in those two. So x minus 2 cannot be 0. Add 2 to both sides, x cannot be 2. That's the only thing in the world x is not allowed to be. You can say it's all real numbers except x cannot be 2. That's another way to say it. Okay, so what about example 3? We have a fraction with an x in the denominator, and we also have an x under a square root. Since it's under a square root, we know that it has to be greater than or equal to 0, right? However, we know that x minus 2 cannot be 0 because it's in the denominator. So, for that particular problem, x minus 2 must be strictly greater than 0, because it has to satisfy both of these rules. If you add 2 to both sides, x must be greater than 2. It can't be equal to 2, it can't be less than 2, it can only be greater than 2.